This is Mastering Mathematics with your teacher, Karen Weston.
Hello Antigua Barbuda, welcome again to another in the series, Mastering Mathematics. As you can see, we have some lovely students here with me today. And you know, yes, they're from the Otis Comprehensive School and the Antigua Girls High School. They are my students. Just in a few years, you're going to see that these people are going to be great mathematicians. So, on behalf of the Ministry of Education, using its EBE unit and Mathematics Education Center and ABS Television, we welcome you once again to another in the series, Mastering Mathematics. Today, I'm going to make them introduce themselves first, and then I'll tell you about our topic, because they're going to show you that this is no mean feat or any play. So we'll start right here with my friends. So look in the camera and tell them your name.
I'm Carida.
Okay, and again?
Shana.
And?
I'm Chantel.
Kenisha. And?
Daphne.
Right. And your goal this time in terms of learning this subject is to do what? What is your aim in terms of studying this subject?
To pass
Right. We are going to pass our mathematics and with distinction. All right. Everything is possible, and especially when we know that God is within the boat. Today, the topic we'll be discussing is vectors. We told you that the last time. You have done your matrices, and my friend here, she's waiting to do her question for the matrices too. And everybody here now, we are going to be learning vectors from the start. From the time we started going into our schools, from the time we get our students in our first form, we introduce them to this thing that we're calling graphs. So these are not new to us. No, these are the things, right? We know that answer up sharp, man. Right, so we know that it's the only time you can talk in this country, right? Good. So we know that these papers, we use them and they are representing our graphs, okay? When we have graphs, what do we say we usually have to have with the graph?
A scale.
A scale, and what else?
An x-axis.
An x-axis and a y-axis. So we have to have an x-axis and a y-axis. And then when we plot something on them, what do we call that?
Coordinates.
We call them the coordinates. Today, they're going to see how those words that they know about coordinates will be transferred to position vector, because we are going to be studying graphs. And so it is not a ground that they're not familiar with. And suddenly they're going to see, oh yes, there is a link and a relationship between our topics. Because, and this is where I'm starting, my friends, they use this paper in school, but I want to use this one because this is the CXC graph paper. And so you'll get accustomed to your size with your squares. But in terms of counting, we count them the same way. Now, if I roughly, okay, because, Miss Weston not doing anything, just draw graphs here, okay? A graph, and we have it here. So we know, just tell me if I'm right, that this is x, this is negative, and this is negative. Yes, and negative. So this is what our scale and our axis looks like. Is that true? Yes. Okay, so we're familiar with that, okay? Now, again, every time we have our axis, we're starting from the origin. That is what we call it. We're starting from the origin. So if I put a point here, okay, and we're counting in terms of the square, and I'm going to call it the letter of my name, which is Karen, so it's C. If I put a point C, we're going to ask everybody, what would be the coordinates of that? Okay, what didn't I put on it? I didn't put? Right, and so, yes, so we have to put 2, and we have to put a 3. Okay, so let's go up in 1 and 2, and let's go up 3 here. Okay, so on this scale, if I was saying a scale, I would have been saying 2 centimeters would be equal to 1 unit on the x-axis, and then on the y-axis it would be 1 centimeter would be equal to 1 unit. So everybody knows that the first thing we're going to put on a graph is always the scale. And so the x and the y-axis do not have to be the same. So 2 cm is equal to 1 unit, and along our y-axis is 1 cm, which would be equal to 1 unit. Okay, now you're going to hold your answers, but look at it, and then we're going to say what would be the coordinate of C. Don't say out the answer, all right? We're going to look around and see. Okay, so we have the point C. Yes. So while they're looking, we have a graph like this. Okay, and it is 0, it is 1, it's 2, and it is 3. Okay, and they're going to tell me what would be the coordinate of a point I have put up here. 1, 2, and I went over, and I'm sure it's over here, and it is C. Okay, and I've asked them to give me the coordinate. Now let me see where I put it. Oh, okay, yes, I put it there. Now, are we ready to say what that coordinate of C would be? Yes? Yes, yes, we're ready. So because we are the dogs of war, man, and we're ready, we're hounding. Oh, and what would we say the coordinate of C? Let's just get it straight on the board here. So that is what I drew for them on the board. Is that right? On our graph paper. So they're seeing it through this eye. So what would be the coordinate of C?
2, 2.
It is 2, 2. What do we mean when we're talking about and saying 2, 2?
2 on the x-axis and 2 on the y-axis.
So it would be 2. So listen, parents at home and the little people who like to tell me they're slow. If you're a little man here and you're walking, okay, the first step we would have to take, right? Good walker. The first step we'd have to take is horizontally every time. Isn't that true? Yeah. Yes. So we're going horizontally every time, and we're walking over to 2 units. So we represent the x position with the first unit, which is 2. And then after that, you say, oh Lord, how much steps I have to climb up now? Because, you know, we like to build our houses on high-rising places, isn't it? Mm-hmm. So then we're saying, how many steps are we going up? 2. So we have to step up here and say, oh, the old knees, granny, but we're getting there, all right? So, and then, so this is 2, 2. So the y coordinate is also 2. All right, so that is what our starting point is. Teachers, we have to establish that our students understand the role of the graph paper, the role of the x and the y axis. How do we read our things? All right? So again, that is why I'm so concerned when you like to tell people that they don't have any foundation. We can take our little time, tell them about this. What is our topic today? It's going to be vectors. What are we showing them? It's a relationship between the graph that they do know already, words like coordinates, which they are using. So they have said coordinates, okay? And it is equal to 2, 2. When we get to our vector, we no longer talk about coordinate. We talk about position vector. So the coordinate becomes the word position vector. Okay, position vector. And why is it being called? So for example, we were looking at C and saying the coordinate of C is 2, 2. In terms of vectors, we would have to say the position vector of C. And to say that, we have to write OC, because every vector has to start from a beginning. The beginning does not have to be the O that we know here. We can be floating here, but in our mind, we must keep this to say, oh, the x-axis would have, so we have to have an imaginary x and y-axis all the time in our brains, okay? Wherever it occurs, that is where we call the origin, okay? But we do the reading on the axis for our graph. So that when we come in here, we put this over here just to help us to say, oh, if it's over here, it's in the second quadrant, all right? And we know, according to our graph, in the second quadrant, the x's are negative. Is that right?
Yes.
And down below, down here, if we had a graph floating down here, a vector floating down here too, then we'd know right away down here that the x's are negative, the y's are also negative, okay? And when we come over here, if we had another vector floating over here, we'd know right away that positive x and negative y, because it's down here. Now somebody's going to say, Miss Weston, you're your student, lost me. So we go back and tell them a little about our x and y axis again, right? So if we had our axes like this, in this direction, everybody along this arm, all the numbers along here for our x's would be positive. And if we went up here, stepping up for our y's also, all the numbers along this place here would be positive. Then when we get now onto this wing of our x, we expect, because we're saying it's negative, that all the numbers, and this is always the origin where they cross, that all the numbers here would be negative. So that is what we're talking about. And then when we come down here on this wing for our y-axis, we know again that all the numbers are negative, okay? But they don't have to be 1, 2, and 3 all the time. It depends on our scale, right? So that is what we're going. So for audience at home, what is happening here when my friends are reading off? We are saying that wherever the vector would be, or wherever the coordinate is, because if I had to write something now, come, my friends, this time we're going to look on the board so that the host guests can also see us. I'm going to try and say, I'm putting a coordinate. Okay, so we're coming here, and I am coming down. Oh, I don't want it to be the same. And I am coming down here, okay? So I have a point, and it is right here, and this time, what you told me your name was?
Carita.
K. So I'm going to put a K right here, all right? Is a C?
Yeah.
Oh, we can't use her because we just use a C already. S. Okay, so here we go. Oh, my mother's name, we call her S. It was Estella, so we say S. Very good. S, all right? If I wanted to get the coordinate of S, what would it be? Take a hard look first and tell me.
Negative 3, 4.
It would be negative 3 and 4. Negative 3 and 4. What type of 4 is it? Positive, because it's up here. So listen again, audience. They know right away. Yes, this time the little man, he's stepping out. So he has changed his face, okay? His face has changed in this direction. And he's ready to step out. So he has to walk along 1, 2, 3. But everywhere along this branch, it is negative. So it is negative 3. And then he said, oh, the people that build the house up here again. And so how many steps he's going up? And we said he went up 1, 2, 3, 4. So we know the horizontal movement is written first and then the vertical. So we get negative 3, 4, all right? And these are called coordinate when we are talking about the graph. So S has coordinate negative 3, 4. If we know the coordinate, we can get the position vector, because all we have to do is to write 2 letters so that what would be the letter? The letters for the position vector of S?
OS.
OS. And we can put an arrow over it too. So we have OS, that is right. And what we do, we write it, you see in here we have a row, okay? And this time it will be written like column for the position vector. So the column vector would be negative 3 and 4. Negative 3 and 4. And these are the questions you get on the examination paper. And people are walking and telling people that how the things are difficult. After 2 minutes in a class, look at the question on the paper. All right? in the simplest form, U1 thing. All right? So the same questions. Again, CXC has not made up anything. Teachers would have taught the lesson. And after this, look at the exam question here. Cameraman, can you zoom in to see? Because you see when we just started this lesson, isn't that true? Yes. And this is the examination question. And I am going to give it to you right now. And you can show after 2 minutes in the vector class, you're ready to get 2, 3, 4, 5, 6, 10, 12 marks for a question. Can you see that?
Yeah.
So what we tell students when they go to school, they have to listen to the teacher. Isn't that right? Yeah. Listen to the teacher. Now, I'm going to give you the base thing that this question has said. In the diagram below, and we're seeing the diagram below here, and it says P, it's okay because we're going to say it, because you're just going to take out the main thing, then I'm going to do it on the board, and we're going to see. P and Q, write this in your book because you're going to tell me the answers for these right now. P and Q are, so P has coordinate 2, 4. P has coordinate 2, 4. And Q has coordinate 8, 2. Tell all when I hear people coming out of the exam room and talking about exam hard, you want one thump in them out, right? How long have we been doing this? Okay, right, 2 minutes and you're ready for the exam question. All right, P and Q. Okay, so P has coordinate 2, 4 and Q has coordinate 8, 2. And it says the line segment, the origin. So at the origin, O would be equal to 0, 0. Okay. Now here, the first question on this. It says, what term is used to describe, oh, just a second for our little audience here. Let's just see. So as you ponder over things, let's let you write down the question. What term is used to describe OP? What term is used to describe OP? That's the first part. And then it says, write each of the following. Write each of the following in the form. Write each of the following in the form. Watch me. And it's the column vector AB. Is the column, oh, let's use this other one, which may be better. Yes, the column vector AB. And here what they want you to write in this form. A, I'm going to draw the thing on the board right now. OP. B, OQ. C, okay. Now see this PQ, I will be talking about. This is the only one you can't do right now because I have not taught you. But this right now, okay? Just leave that one. But the first two, OP and OQ, and they have asked you to say, when you see something written like this, OP, what does it mean? Okay, so that's your first part. What term is used to describe OP? And then you're writing each of the following in the form AB. So you have, and AB stands for X and our Y's. And so you have to write OP in that form and B in that, and OQ in that form. I'm going to send the audience on a little break so I get the diagram on the board for them. And you're going to write your answers. So when we come back, we're going to see if we are correct. Okay? So cameraman, you can just watch them doing a little work in between and then let them go on a little break. So let them relax for a little while. So audience, take your break. Okay, so you just write down your answers.
Whenever possible, draw a diagram. Even though you may be able to visualize the situation mentally, A hand-drawn diagram will allow you to label the picture, to add auxiliary lines, and to view the situation from different perspectives.
To succeed in mathematics, you need to build on what you've learned before. New concepts are added to and build upon previous concepts. It is very important that the early material be mastered thoroughly. Similarly, mastery of material from previous classes makes success in later classes more likely. So continually review and practice concepts from previous sessions.
Don't look on what I cannot do. Focus on what I can do. I may not say what I do, but I can hear and feel it as strongly.
I may not hear, but that does not and should not affect my ability to learn and to function in the real world.
I am a gifted student. I need the opportunity to soar. Support me in my climb to higher levels of learning.
Some of our children have special educational needs. They have a right to an education. So let us teach them the way that they learn and help them to achieve their full potential. All right, so we sent you on your break and we were busy little bees here, okay? Because we had a task to fulfill. I also had to show you that everything that is being taught in school, teachers, we have to show the students how it's associated with the examination question. We spent at least the first 10 minutes doing something. What did we do? We brought them back. We made certain that they know that they're on easy home ground. They're accustomed to the graph. They know their x and their y's. They know their axes, all right? And so we link it to the next topic that we're getting, which is our vectors. And so we see the connection that we're using things for coordinates, that we are now switching to the term position vector. Our first little lesson then is to tell them that in terms of saying that we want to find the position vector, it is still like our coordinate movement, the movements for our coordinates, but in terms of position vector, we write them in a column bracket. And every time for the vector, so we say a vector, it has direction and it has size, okay? And we say every time for the coordinate or the position vector, the x coordinate is written first, which is the horizontal movement, and then the second position is the y coordinate or the vertical movement. Now I am now showing my friends there's no mystery in these exams, okay? So the first examination question, and it came from the CXA exam 2014, last year's question, and it said in the diagram below, so you get your coordinates and they ask you to change them to position vector. So we would understand too, if they gave us position vector and asked us to do the coordinate, we know we just have to express it as a row vector. All right? So let's see how smart my students are, because they're smart, you know. Oh yes. Here we go now. So, and they were eating ice cream, so you know. All right, their bellies are full. So here we are. It says in the diagram below the coordinates of P. And so we have P would be 2, 4, and Q is equal to 8, 2. And it says the line segment joining the origin is 0, 0. So this part here would have been 0, 0. And then it says to the point P may be written as OP. That is how they say it may be written, this, all right. What term is used to describe OP?
Position vector.
Position vector. That's your 2 marks for that you get on the exam question. And you see on our line, I didn't make it up. Position vector. And here it is. Write each of the following in the form AB. So what is OP? 2, 4. And how am I writing it? Column. In a column, and it is 2, 4. All right? And what is OQ? 8, 2. And how am I writing it? Column. In a column, 8, 2. What? And peak, you want to do PQ? Yeah. All right. So listen, you hear my people? They're telling me that they want to do PQ. Now, again, what are we noticing? It says the letter that they are talking about. It means that we are walking from here to here. Isn't that true? Yes. Okay, so what are you telling me PQ is?
2, 4, and 8, 2 in columns.
Tell me again.
2, 4, and 8, 2 in columns. But they're put together. Like me.
Oh, so you see, no, it's still a distance, you know, right? It's still a distance. But what are you telling me? I'm writing it in columns? How am I writing it?
2, 4, 8, 2.
In this?
Yes.
Oh, right. Now, parents, so you see, when they don't have the knowledge, they can't know it. So teachers, we have to teach them. If there is a gap in knowledge, we have to fill it in. So this time, that is not going to be true. And watch them giving me the correct answer after my just telling them exactly what it is. Okay? So, I have not taught them this part of it yet. So the knowledge is just not there. But don't you see students are willing and ready to learn? Yes. Because once we give them the information, that is what it's going to be. And we have to grab their interest. If you have to be a comic, be a comic. All right? But they are here. Watch their little eyes. They're waiting to learn something. Watch the expectancy. All right? And look at my leaders. Okay? And my dear quiet one here too. Okay? But everybody is waiting. Now, I have taught them. Okay, so they know the position term, and in 1 minute they're saying it. Here. This is my next lesson where I'm going to teach them that every vector question can be solved using a triangle. But an information is missing, and that is the one I had to work on you with, right? Every vector question can be solved using a triangle. We took you right down to the wire. We don't have another minute to spare in this session. So, I hope, and I must call up Nurse Gums because she is watching. Along with all the 90s, Miss Shepherd and all these people in All Saints. Our grannies and our aunts are walking at this. And Gumsy, I am glad that you're enjoying it and that there is something for you to enjoy for the balance of your life. Having struggled so hard to make certain that we are healthy and we have a healthy nation. Thank you very much. And we are going to continue to entertain her. Isn't that true? Yes. All right. Do we want to say anything to anybody? No. We are learners in this place. We don't have time to talk, okay? And we have to hold on to the knowledge that we conquer. So, until tomorrow, we're going to let you go. And I hope you had as much fun as we had learning the first session of our vector. See you again tomorrow.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.